Good morning, I am Dr. M. Patra. I will be going to teach chemistry. The topics given to me: compounds containing nitrogen. Now, there are three different classes of compounds which contain nitrogen. Number one, compounds containing nitro group, that is NO2 group. This is the functional group. Like there are two types, nitroalkanes and nitroarenes. The second category is compounds containing cyanide group. Common name is cyanide, but UPAC name is nitrile, N-I-T-R-I-L-E. They can be either alkane nitrile, commonly called alkyl cyanide. The second one will be arene nitriles, or aryl cyanides. The third category of compounds which contain nitrogen are amines. Amines, A-M-M-I-N-E-S. Your course includes only this class of compound, like nitro group containing compound or cyanide group containing compounds are not included. Amines are again three types. One is called primary amines, second one is called secondary amines, A-M-M-I-N-E-S, secondary amines. Third one is tertiary amines. Amines may be thought is a derivative of ammonia. As you know, ammonia is NH3. It is not an organic compound since it does not contain any carbon atom. When one or more of its hydrogen atoms are replaced by one or more alkyl groups, we get amines. Therefore, I have already written it can be a primary amine or secondary amine or tertiary amine. Let us come to the primary amine first. When one of the hydrogen atoms of ammonia is replaced by one alkyl groups, we get primary amine. So, general formula of primary amine will be RNH2, where NH2 is the functional group called amino group, When two of the hydrogen atoms are replaced by two alkyl groups, both the alkyl groups may be same or both the alkyl groups may be different. This gives to what is called secondary amines. Here the functional group is NH, called imino group. Mark the difference of the spelling. Another is the amino group, here it is called imino group. The third category of amines is a tertiary amine. When all the three hydrogen atoms of ammonia is replaced by alkyl groups, 3 alkyl groups, all may be same or all may be different, or 2 of the alkyl groups may be same, 1 is different. So, this is your tertiary amines. Here the functional group is the nitrogen atom called tertiary nitrogen atom. Due to shortage of time, I am not going to discuss their nomenclature, which is being taught to you in your first year class. Next, I shall proceed the general methods of preparation. I mean, by general methods of preparation, we can prepare all types of amine. Only one method I am telling, it is from alkyl halide. When alkyl halide treated with ammonia, we get primary amine. Rx, as you know, it is your alkyl halide. Ammonia is your NH3. One molecule of hydrogen halide is eliminated. You are getting primary amine. This primary amines, once you got, can further be treated with another molecule of alkyl halide, when you will get HX and secondary amine. Secondary amines may further be treated with alkyl halide, when you can get HX and tertiary amine. But if tertiary amine is further treated with alkyl halide, you will get a salt, that is R3N. I can write in short tertiary amine. We can treat with alkyl halide, when we will get R4N plus X minus. This is called quaternary ammonium halide, or in general it is called a salt, quaternary ammonium salt. So, I mean by general method of preparation, you can treat alkyl halide of different amounts with ammonia, when you can get primary, secondary and tertiary. Next, I shall proceed to prepare only primary amine, and once we get primary amine, we can get secondary amine, and once we get secondary amine, we can also get tertiary amine on treatment with alkyl halide. So, next I am proceeding to preparation of primary amine. There are few methods. Number 1, I am telling the source. First source is nitroalkanes. Process is known as reduction. There are 2 different ways. Small a, acid medium reduction. When Nitroalkane is reduced by or heated with a mixture of tin hydrochloric acid or iron and hydrochloric acid. Then the nitro group is reduced to amino group RN2 converted to RNH2 with elimination of one molecule of water. This is your nitroalkane. This is your primary amine. So we call it acid medium reduction since we are using acid like hydrochloric acid. So two reagents we can use. One is your tin hydrochloric acid or iron and hydrochloric acid. The second process to get primary amine from nitroalkane is by using, or that is called catalytic reduction. In this method, the nitroalkane is reduced by a stream of hydrogen, that is hydrogen gas, in presence of either nickel or platinum or palladium as catalyst. When nitroalkane is reduced to primary amine along with the elimination of one molecule of water. So this is the first source, that is from nitroalkane. The second source is from alkyl cyanide. Alkyl cyanide. The same we apply the reduction process here also, but the reducing agent is a bit different. When alkyl cyanide is reduced by lithium, aluminum hydride, lithium aluminum hydride, you will get primary amine. Alkyl cyanide is RCN. When we write hydrogen within square bracket, it represents reduction. Reducing agent is lithium aluminum hydride. Here 4 hydrogen atoms, 2 attached to carbon, 2 nitrogen, which leads to or gives primary amine. So this is the another way. Third source is from acid amide. So alkyl cyanide reduction by lithium aluminum hydride gives you primary amine. The third source is acid amide. There are 2 processes. Remember, it is important. When acid amide, it gives you 2 different types of primary amine from number 1 by reduction. By reduction. When acid amide, general formula is RCONH2. Here also the reducing agent, you can take lithium aluminum hydride, or another is also there, a mixture of sodium and ethyl alcohol. When hydrogen will be produced, it will be a reducing agent. Now here acid amide, when heated with lithium aluminum hydride or sodium ethyl alcohol, you will get an amine, primary amine, having same number of carbon atom. There is no change in carbon atom. same number of carbon atom plus water. Remember, underline the words having, from having onward, having same number of carbon atoms. There is no change in carbon atom. Let us take an example. If we take CH3CO and H2, common name is acetamide. Under this condition, that is, it is subjected to reduction either by using lithium aluminum hydride or sodium ethyl alcohol mixture. When heated, you will get CH3, CH2 and H2. There is no decrease in carbon atom. Number of carbon atom remains same. This is your ethanamine. So this is one method of getting primary amine from acid amide. When acid amide is subjected to reduction, you are getting a primary amine having same number of carbon atom. The second way from getting primary amine from acid amide is important, called Hofmann's degradation. The word degradation is used since there is a decrease in carbon atom. In this process, when acid amide is heated with a mixture of bromine and potassium hydroxide, you will get a primary amine having, underline the words, from having one carbon atom less than the acid amide. Since one carbon atom become less, therefore the process is called degradation, names after Hofmann, therefore it is called Hofmann's degradation. So if you are taking acid amide, in general RCONH2, when heated with bromine, here I am balancing it. Normally organic reactions are not balanced. You will get RNH2, one carbon atom become less, potassium carbonate, potassium bromide and water. So it is your acid amide. You are getting a primary amine having one carbon atom less than the acid amide. If you are taking same acetamide, under this condition, that is heated with bromine with potassium hydroxide, you will get a primary having one carbon atom less. So you can see you are getting methanamine. Here one carbon atom is less, methanamine. So from acid amide, there are two processes of getting primary amine. One is reduction, when the number of carbon atom the acid amide remain constant in the primary amine. By Hofmann degradation process, you are getting a primary amine, one carbon atom becomes less. So I have underlined it, having one carbon atom less than the acid amide. Therefore it is called degradation, named after the scientist Hofmann. So this is another method of preparing primary amine from acid amide. The next process is by named after a scientist Gabriel, Gabriel's thalamide reaction. Mark the spelling thalamide. It is pH here, P remains silent. pH, THALIMIDE. Thalamide formula is, it is an amide. It is an amide. CONH. This is your thalamide. When thalamide is treated with potassium hydroxide dissolved in water, that is called alcoholic potassium hydroxide. Here, one of the hydrogen atom from NH2 group is replaced by potassium and you are getting water. This compound name is potassium thalamide. The potassium thalamide, once you get, again treated with an alkyl halide. When potassium halide is removed, giving you an alkyl, this is called an alkyl thalamide. An alkyl thalamide when subjected to hydrolysis, here the bond breaks, OH, H, dotted line is the breaking line, OH, H. You are getting phthalic acid and primary amine. Phthalic, pH, THALIC, phthalic acid. Already I have told you pH remains silent. You are getting RNH2. This is your primary amine. So these are the few methods of preparation of primary amine only. I have discussed 4 different sources. One is from alkyl halide, second alkyl cyanide, third acid amide, fourth is from thalamide, named after the scientist Gabriel. It is called Gabriel's thalamide reaction. Next we shall proceed how we can get secondary amine. Now, secondary amine, remember, when alkyl cyanide is reduced, we are getting primary amine. But when alkyl isocyanide is reduced by either lithium aluminum hydride or by mixture of sodium and ethyl alcohol, we will get secondary amine. Alkyl isocyanide structure is NC. There is a double bond between nitrogen and the carbon atom, and a lone pair of electron from nitrogen is donated to carbon. This is your alkyl isocyanide. Reduction I have told you, will write within hydrogen within a square bracket, reducing agent lithium aluminum hydride or a mixture of sodium and ethyl alcohol. You will get RNH CH3, this is your secondary amine. Secondary amines. So this is only one method of preparing secondary amine, but we can use all the methods of preparation of primary amine to prepare secondary amine. Once we get primary amine, we can treat. Say for example, primary amine is RNH2. You can treat another alkyl halide. Here R and R dash may be same or different. When you can get secondary amine and HX. So this alkyl group, carbon atom, and the originally carbon atom present in the alkyl group may be same, may be different. That is a choice there. So once we get primary amine, we can prepare secondary amine. Then all the methods we have discussed in connection with the primary amine we can utilize here also. That means only one step more, treat with another alkyl halide. Next is preparation of tertiary amine. Once we get secondary amine, we can treat with another molecule of alkyl halide when you can get tertiary amine along with the elimination of HX. This is your tertiary amine. So from secondary amine we can prepare the tertiary amine. So once we get primary amine, we can treat with alkyl halide having the same number of carbon atom or different number of carbon atom. We can get secondary amine. Once we get secondary amine, we can treat with alkyl halide having same number of carbon atom or different number of carbon atom. We can get tertiary amine. So these are the few methods of preparations of amines. Next we shall proceed to their properties. Most important is amines are basic in nature. It is most of the time asked as a question, why? Now here the answer is an organic compound. I am writing here an organic compound becomes acidic in nature, basic in nature, when it is capable of donating a pair of electrons. This is according to Lewis theory. Lewis theory of acid and base. So according to Lewis concept, an organic compound becomes basic in nature when it is capable of donating a pair of electrons. All amines, I am changing the language, the nitrogen atom of all amines contain a lone pair of electrons which can be donated. Therefore, amines are basic in nature. So if the question asks why amines are basic in nature, you shall have to write these things. An organic compound becomes basic in nature when it is capable of donating pair of electrons. That is according to Lewis' concept of acid and base theory. The nitrogen atom of all amines contain a lone pair of electrons which can be donated. Therefore, amines are basic in nature. Sometimes another question also asked from here, so that amines are basic in nature. That means prove that. Why amines are basic? Prove that by reaction amines are basic in nature. We know ammonia is basic in nature. There are two reactions I am supporting in this connection. Like ammonia, it reacts with hydrochloric acid. So number one you write action with HCl. Like ammonia, it reacts with hydrochloric acid, forms salt. Ammonia reacts with hydrochloric acid, we get NH4 plus Cl minus. This is called ammonium chloride. Similarly, all amines, let me start with primary amine. It reacts with hydrochloric acid, you will get RNH3 plus Cl minus. If you will take secondary amine, R2NaH in general I am writing, react with HCl, when you are getting NH2 plus Cl minus. And tertiary amine react with also hydrochloric acid, you are getting R3NH plus Cl minus. These are called either amine chloride or amine hydrochloride. So you can see, like ammonia, which is a base, which react with HCl form ammonium salt. So also all amines react with hydrochloric acid, forms amine chloride or amine hydrochloride it is called. The second reaction in support of the question that why or so that amines are basic in nature is action with sulfuric acid. Like ammonia, all amines react with sulfuric acid, forms salt. Ammonia react with sulfuric acid, gives you ammonium sulfate, NH4 whole 2 SO4. This is your ammonium sulfate. Similarly, all amines, primary amine also react with sulfuric acid, like ammonia, when you will get addition compound. So also secondary amine reacts with sulfuric acid, you are getting R2NH2 whole 2SO4. And tertiary amine also react with sulfuric acid, when you are getting these are addition compound with sulfuric acid known as amine sulfate. So these are the two reactions which supports that amines are basic in nature. One, we can write with hydrochloric acid when we are getting addition compounds, that is got amine chloride or amine hydrochloride. Another with sulfuric acid when we are getting amine sulfate. Next important part is comparison of basic strength. Which amine will be more basic than which one? Now, in this connection, you should remember that more the amount or the more the electron density, more the electron density over the nitrogen atom of the amines, more is its basic character. More is its basic character. Once the electron density over the nitrogen atom increases, it will be capable of donating more electrons, means it will be more basic in nature. Therefore, in short I have written, more the electron density over the nitrogen atom of amines, more is its basic character. You know from hyperconjugation that methyl groups or alkyl groups in general, alkyl groups are electron pushing groups. Therefore, more the alkyl group, more the alkyl groups, more the alkyl groups, more is the electron density or electron density over the nitrogen atom of the amines, and hence more is the basic in character. So, what we conclude with that? Now, alkyl groups or methyl group, whatever you write, are electron pushing groups. Therefore, more the alkyl groups, more is the electron density over the nitrogen atom of the amines, and hence more is the basic in character. Therefore, we expect that tertiary amine, which contain 3 alkyl groups, will be more basic than the secondary, which will be more basic than the primary. This is the theoretically. Alkyl groups, electron pushing group, I have shown by arrow. This should be more basic than secondary amine, which should be more basic than primary amine, and which should be more basic than ammonia, because in ammonia there is no electron pushing groups. All the nitrogen atom in all these cases possess lone pair of electron. So, theoretically this is your tertiary amine. In short I have written here, this is secondary amine, this is primary amine, and this is your ammonia. This should be, this is a theoretically concept. Theoretically, it should have been that tertiary amine should have been more basic than secondary, then primary. But actually it never happens. It is observed that, which is practically, when you in the examination you will write practical things. The secondary amine is more basic than primary amine, which is more basic than tertiary amine, which is more basic than ammonia. This practically happens. That is, secondary amine is more basic than primary, then primary is more basic than tertiary, which is tertiary amine, which is more basic than ammonia. Because, like you'll write and underline it, this is due to steric hindrance or obstacle in space. You see, the meaning of this steric hindrance or obstacle in space means there is more electron density, no doubt, over the nitrogen atom of the tertiary amine, but due to these bulky alkyl groups, the incoming group cannot reach the nitrogen atom of the tertiary amine. So this hindrance or obstacle in space, steric word is coming from space, is known as steric hindrance or obstacle in space. So if in the examination it asks, say for example, I am giving, arrange the following in the increasing order of the basic strength. So say one is methanoamine, another is N-methyl methanoamine, another is NN dimethyl methanoamine. This is a primary amine, this is a secondary amine, this is a tertiary amine. So most basic will be N-methyl methanoamine, more basic than methanoamine, which will be more basic than NN dimethyl methanoamine, will be more basic than ammonia. So this is the comparison of their basic strength. So amines, I am repeating once more. So a lot of question comes from in this connection. Number one, why amines are basic in nature, already I have told you. Second question will come, why amines, so that, why amines basic in nature, already we have told. So that amines are basic in nature, two reactions I have given in support of the answer. And sometimes ask, compare the basic strengths of the amines, or objective question given, which of them is more correct. Out of four choices, which one is correct. The next reaction will go to action with acetyl chloride. Action with acetyl chloride. Here only primary and secondary amine reacts. Both primary and secondary amine react with acetyl chloride in presence of a base like pyridine to forms corresponding acetyl derivative. Let us take primary amine RNH2 acetyl chloride. I have written in a reverse way, acetyl chloride, that is CH3COCl. This is your primary amine. We have taken a base, resin is that pyridine, HCl is formed here. To neutralize that hydrochloric acid, base is taken. When you are getting, this is your N-alkyl acetanilide, N-alkyl. Yes, correct name, the UPAC name I am writing once more, N-alkyl acetamide. The secondary amine also react, R2NH, also react with acetyl chloride in presence of base like pyridine. Pyridine is used to neutralize the hydrogen chloride form acid. This is your secondary amine. This is your acetyl chloride. You will get HCl will be neutralized by the base. This is your NN dialkyl acetamide. Or ethanamide you can write. Tertiary amine does not react. Sometimes ask why tertiary amine does not react. Because its nitrogen atom does not contain any hydrogen atom. Remember, if it is asked why tertiary amine doesn't react with acetyl chloride, right? The nitrogen atom of the tertiary amine does not contain any hydrogen atom. Therefore, tertiary amine doesn't react with acetyl chloride. Next, third reaction is most important. Action with nitrous acid. Action with nitrous acid. You will find in the book, inside of the nitrous acid, it is written in situ. What is its meaning? It means prepared at the reaction site. We will not get nitrous acid in the laboratory. We prepare by taking sodium nitrite and hydrochloric acid, when you will get sodium chloride plus nitrous acid. This is a nitrous. It is observed different amines behave differently towards the nitrous acid. When you take primary amine, PIT1, any primary amine when treated with nitrous acid, you are getting alcohol plus nitrogen and water. Remember, the nitro group may be attached to, amino group, not nitro, the amino group may be attached to any carbon atom. When treated with nitrous acid, you will get an alcohol where entire amino group is replaced by OH group. The alcohol may be formula, may be primary, secondary or tertiary, whatever may be. So, you are getting alcohol. Remember, the amino group attached to carbon atom is replaced by OH group when we get primary amine. When secondary amine treated with nitrous acid, you get a nitroso compound. You will get a nitroso compound along with the elimination of water. This is a yellow liquid nitroso compound. This is a yellow liquid nitroso compound. Sorry, here little mistake in structure. Two alkyl groups, here R and R, single bond, double bond. Please correct it. So, nitroso compound. On the other hand, when tertiary amine treated with nitrous acid, you will get tertiary amine. This is a tertiary amine. This is secondary one. With tertiary amine, you will get an addition compound R3NH plus nitro. That is your nitrite. It is a salt-like compound, nitrite salt. Nitrite salt. So remember, three different types of amines. We have three different ways. Primary amine gives alcohol. the amino group replaced by OH group. Secondary amine gives nitroso compound, and tertiary amine forms an addition compound, that is nitrite salt. Next is the carbyl amine reaction. Carbyl amine reaction. This is most important. Most of the time it is asked in the exam. When carbyl amine reaction is asked, you will write the carbyl amine reaction is only responded by primary amine. Primary amine. No other amines will respond carbyl amine reaction. Primary amine. So primary amine, when treated with chloroform and potassium hydroxide. Primary amine, when treated chloroform and potassium hydroxide, you get alkyl isocyanide. Alkyl isocyanide, this possesses an obnoxious smell or foul smell, foul smell. Alkyl isocyanide. This is only responded by primary amine. So these are the all about the aliphatic amines, that is we have discussed today. We will be going to discuss next time the aromatic amines. Thank you.